Hello, everybody. We're going to continue talking about section 17A, kinematics. And in our last video, we were working through example 2, but we didn't actually get to draw a motion diagram for the particle. So I just wanted to show you what that looks like. Okay. So you might remember that we had a sign diagram that looked something like this. And even though this is a different file, so if the sign diagram looks slightly different, the signs are still the same. Between 0 and 2 seconds, my particle is moving to the right. Between 2 and 5 seconds, my particle is moving to the left. And between 5 seconds and continuing to infinity, my particle is moving to the right. So when I want to draw a motion diagram, I'm going to draw a line indicating the distances. I'm just going to indicate the key distances. My particle was, when I started at at time 0, my particle is 3 meters to the right of the origin. Then it moved to the right all the way for the first 2 seconds. At time 2, my particle was 55 meters. I used my displacement equation. It's 55 meters from the origin. Then it turned around and it started to go to the left. And it went to the left all the way until t equals 5. Now, when at time 5, my particle is 28 meters from the origin. So it went all the way from 55 meters away to 28 meters from the origin, and then it turned around and started to go to the right. When you draw a motion diagram, it's important to include key times and key distances. Now, building on that same example, we're going to talk about finding the speed of the particle at 3 seconds, and to determine if it's speeding up or slowing down, and then to find the intervals when the particle is speeding up and slowing down. So remember that to calculate speed, we need to find the signs of both the velocity and the acceleration. So the sign of the velocity when at time 3 is negative. It's negative 12 meters per second. And that means that the actual speed is 12 meters per second, but it's moving in a negative direction. Likewise, the value of acceleration at time 3 is negative 6 meters per second squared. And since the signs of both of these match, they're both negative, that means the particle is speeding up at that point. Also notice that your IB book likes to write things with negative exponents, they're units. I tend to write it more like this. Both are acceptable. Okay. We also need to find out when the particle is speeding up and when it's slowing down on the interval of 0 to 10 seconds. So to figure that out, I need to know the signs of the velocity and the acceleration. So I'm going to make a sign diagram. Okay. The first thing I need to do, though, is in my sign diagram, I already know velocity is 0 at 2 and 5. But to complete my sign diagram, I need to know when the acceleration is 0. And acceleration is 0 when 12t minus 42 is equal to 0, or when t equals 3.5. So that has to be included in my sign diagram. Anytime that the first derivative, that the velocity is 0 and that the acceleration is 0. And we already knew that between 0 and 2, my velocity was positive, and bigger than 5, my velocity was positive, and in between, my velocity was negative. Now I just need to think about my acceleration. So remember that my acceleration, I could rewrite that as 2 times 6t minus 21. And I just have to ask myself, if I pick a number between 0 and 2, so say I pick 1, is this going to be positive or negative? Well, my acceleration is going to be negative. If I pick a number between 2 and 3.5, say 3, 12 times 3 is 36. This is going to be negative again. If I pick a number between 3.5 and 5, like 4, 12 times 4 is 48, minus 42 will give me a positive. And if I pick a number bigger than 5, say 10, this is going to be way bigger and going to give me a positive result. Now I can analyze. When the signs are not matching, it's slowing down. When the signs are matching, it's speeding up. Here the signs are not matching, it's slowing down. And here the signs are matching, so my particle is speeding up. And that is it for kinematics. Thank you.